So it's easy to see that subtraction is not commutative. As an example, 5 minus 2, is that the same as 2 minus 5? That's the question.
One would be a negative number.
Yes, so 5 minus 2 is what?
5 minus 3.
Is 3. And then 2 minus 5 is negative 3. So subtraction is not commutative. Mm-hmm. The same thing for division. Division is not commutative. Division is not commutative. So for example, 8 divided by 2, is that the same as 2 divided by 8? No. What's 8 divided by 2? 4. What's 2 divided by 8? Reduce, what's that? 1/4. And 4 and 1/4 are not the same number. 1/4 is smaller than 4. All right, so commutative property only applies to what operations? Multiplication and addition. So for subtraction and division, the order does matter. So just remember that the order does matter. Commutative means it does not matter. All right. Now, so that's commutative property. Let's talk about associative property. All right, the associative property.
I'm sorry, what is the subtraction and division called again? Because it's not a commutative property.
It's not called anything.
So it's not, okay, I just want to make sure.
No. So the commutative property only applies for which operations? Addition, multiplication. When you subtract two numbers or divide two numbers, the order does matter. So that's why it's not commutative. All right, so the next one's called the associative property. A-S-S-O-C-I-A-T-I-V-E. The associative property. All right, and so when you associate with other people, you're associating with groups.
Right.
And so when you think of the associative property, think of the word groups. So I'm going to put the word groups in parentheses. Now don't call this a group property. It's called the what? Associative property. Just think of grouping when you use the associative property. All right, so let's talk about the associative property of addition. All right, so just like with commutative property, we're going to talk about those two same operations, addition and multiplication. So part A, addition. All right, so when we think of the associative property, we're thinking of three or more things. So I'm going to write three numbers here. I'm going to add three numbers. So let's say I'm doing this as an example. So let's say I had 2 plus 3 plus 4. Just write it like that for right now. 2 plus 3 plus 4. All right. Now, if I group, notice the word group. So if I group the first two, and we think of grouping, you think of those symbols, parentheses, brackets, and so on. So if I group the first two numbers like this, is that the same? The question, is that the same? And we'll write the same order. I'm going to say 2 plus 3 plus 4. So when using the associative property, order that you have those numbers listed have to be the same. Is the grouping that's different. So I'm grouping the first two. Is that the same as if I were grouping the last two? Yes. Using the order of operations, I do parentheses first. 2 plus 3 is 5. 5 plus 4 is 9. Do parentheses here. 4 plus 3 is 4 plus 3 is not 9. 4 plus 3 is 7. 7 plus 2 is 9. So the associative property of addition says that the order in which you group things is not going to matter. Now again, though, you're assuming that 2, 3, and 4 are in the same order. Okay? So we talk about grouping, and it's normally 3 things in this section that you're grouping. So when you use the associative property of addition, you're going to group the first 2 things, and then the next side, you're going to group what? The last 2. Okay? All right, so that's the associative property of addition. In terms of letters, it would be A plus B plus C equal A plus B plus C. So A plus B plus C equal A plus B plus C. So in the first group, let's suppose I group the last 2 like this. If I am using the associative property, then on the other side, which group must I put in parentheses? A and B. A plus B. All right. Okay? So notice A, B, and C stayed in the same order. You don't change the order. When you change the order, you're using the commutative property as well. I just want you to use the associative property. So the order stays the way it is on both sides. You're just changing the groups. Okay? And again, you could have said this, just to be aware. You could have said group the first 2, and then what here? Group the last 2. All right. So A plus, and then B plus C is in parentheses. Over here, A plus B is in parentheses. And then there's an associative property for multiplication. Okay, multiplication. Okay, so as an example, instead of addition, this time it's multiplication. So as a numerical example, let's suppose I had 2 times 3 times 4 equal 2 times 3 times 4. So we know that those 3 numbers multiplied together, those 2 sides have to equal each other. For one thing, it's the same numbers multiplied together, the same order. So the associative property says you're grouping things. So I can group 2 times 3 together. Oops, I didn't mean to put this multiplication symbol here. Right here. All right, so I can group 2 times 3 together. And it's saying that that left side is going to be the same as the right side, even if I group what together over there? 3 times 4. Just like that. And it's true because order of operations was 2 times 3. 6 times 4 is, on this side, what's 3 times 4? 12 times 2 is 24. And so the in terms of letters, A, B, C equal A, B, C. A, B, C equal A, B, C. All right, so I can group the first 2. That's the same thing as saying grouping what? The last 2. Those 2 sides will be equal to each other. Or I could have grouped B and C together, and over here group what? A and B. Right, so that's the associative property. Associative property dealing with groups. Okay. All right, so the order in which you group things does not matter. It's basically what it's saying. Now, we don't have one for division. We don't have one for division. For one thing, it really, for example, just to show you, if I said 4 divided by 2 divided by, let's say, 6. So all division. And over here, 4 divided by 2 divided by 6. All right, so I can group the first 2 and then group the last 2 and see that is still correct. What's 4 divided by 2? 2. And then, so that's 2, right? And 2 divided by 6, which means this, is 1/3. All right. Yep. Yeah. So 4 divided by 2 is 2, correct? And then 2 divided by 6 is 1/3. Y'all agree? All right, let's check this side. What's 2 divided by 6? 1/3. So that's 4 divided by 1/3. Y'all agree? Last semester, what'd you do when you divided fractions? You changed, you use a LCD only when you add or subtract. You change the division to multiplication. So you said 4 times the reciprocal of 1/3. What's the reciprocal of 1/3? 3 over 1 are just 3. And what's 4 times 3? 12. So you see 1/3 is not the same as 12. So
you have that in any problem, that's what you're gonna do.
say it again.
I said that's what you're gonna do in any problem. You're gonna calculate that. And
Whenever you're dividing fractions, you're going to change division and multiplication. So you get, say, times the reciprocal of the second fraction. Okay?
and what rule is that?
There's really, it's not a rule, it's just something you had to remember from last semester. You're changing a multiplication, you change a division multiplication. So to change the division multiplication, the first fraction stays the same, you say times the reciprocal of the second fraction.
Wait. I need you to go over that again. How did we get to changing division to multiplication? Because I was caught up and trying to take notes.
Okay, so let's remember something from last semester. If I have, I'm doing it once, so listen carefully. If I have 4/3 divided by 2/5, what did y'all do last semester? You said 4/3 times the reciprocal of 2/5. What's the reciprocal of 2/5? 5/2. All right, now again, last semester, you can multiply first and then reduce, or you can reduce first and then do what? Multiply. So let's reduce first. 2 into 2 is 1. 2 into 4 is 2. Now multiply. What's 2 times 5? What's 3 times 1? 3. You can leave it as a fraction, or you can change it to a mixed number. Okay? All right. Yeah, it's in, if you bought the book, it's in there. So you just, some of you may need to go back and review some things from last semester. Okay? But you have the book?
Yeah, I do.
Okay. Just look up in the
That's what
index.
the rule, but there's
Yeah.
no rule to it.
It's not called a rule. Okay, now let's look at this. Okay, so according to the order of operations, what would you do first if we use the order of operations? Parentheses. 3 plus 4 is 7. So using the order of operations, so you said 2 times 7, correct? And the 2 times 7 is 14. Okay. Now, in this section, now this was the last section. That was section 8.2. In 8.6, there's also a property. Remember, these are called properties of real numbers. There's also a property called the distributive property. So let's talk about the distributive property. All right, the distributive property. Okay, so the distributive property is basically where you're going to have something in front of parentheses, and you're going to have a set of parentheses. Something like this. Looks like this. This operation that's inside this parentheses, and it doesn't have to be addition, but it could be subtraction, but this operation here is addition. What is this operation right here that I'm pointing to? Multiplication. So you learned, and you did this last semester, you learned last semester that you can also write this as 2 times 3. We'll go ahead and write it like this. 2 times 3 plus, and then 2 times what? 4. That's the distributive property. So everything that's inside the parentheses, you are multiplying by what? 2. All right. And then you said 2 times 3 is 6, and then 2 times 4 is 8, and then 6 plus 8 is 14. Okay. All right. Now remember on that worksheet it said that you turned in, and there was a problem like this, and I told you when I gave it out, I said don't use a distributive property because distributive property is not an order of operations. So you have to use the order of operations when doing that particular problem. All right. Now let's look at this.
On the test, you give us the same exact problem, but one says to do the distributive property, and the other says order of operations, you want us to do it like 2 times 7, and then on order of operations, and on this one, you want us to do it like that? Is that what you're saying?
Yes, order of operations is this one. Distributive property is this one. Those are parentheses. That's distributive property. Okay? All right, let's look at number 32. You have 7 times A plus B. 7 times A plus B. Now, you can't use the order of operations here to begin with because you cannot combine A and B. Those are letters. Right, so we're going to learn soon something about what you said, unlike terms. So you have to use distributive property. In the directions, we'll say multiply using distributive property. So you're going to write this as 7 times, and you're going to, if it helps, you use those arrows like this. You don't have to, but sometimes it does help. So this is going to equal 7 times A, and what's 7 times A? 7A, plus 7 times B is just 7B, and you're done. Don't write this as 14AB because those are not like terms. You're going to learn about like terms in a little while. 38. All right, 38. You have something that looks like this. All right, go ahead and use a distributive property. So how would you write this? You'd say, in your mind, you'd say 8 times what? I'm sorry, 3 times what? 8x, which is 24x, minus, and then 3 times 1, which is 3. And there's your answer. Distributive property. All right, now last semester you also learned that a negative times a positive is a negative. You also learned that a negative times a negative is a positive. Okay, so look at 42. 42. Looks like this. Now this is a z minus y. That's a y. Z minus y. Z minus y. All right. Okay, so a negative 3 times a positive z is a negative 3z. Plus what? Plus 3y. A negative times a negative is a positive. So a negative 3 times a negative y is a positive 3y. And there's your answer. Okay. 48. All right, let me find it. Let's see. All right, 48.
I have a question.
Uh-huh.
On how you prefer. So whenever I write my negative 3z plus 3y, I put a multiplication dot in between those two.
That's fine. It's just that if you put too many operations, it starts to look a little bit messy.
Okay.
So she's saying, is it okay to have done this? It just gets a little bit more messier the more operations you put in there. So we prefer that you know that the multiplication is not there. It's understood to be multiplication.
Okay.
All right. So this is a preferable way to write it.
Okay.
All right. 48. All right, 48. You have this. Looks like this. All right, so how many things do you see inside that parentheses? 3. And then plus 16 over here. That's 5R. Yeah, it looks like a 5. That's 5R. I know, but it's 5R. That's 2P.
P like Paul. 4 plus 2P.
Plus 5R. So negative 4 times 4 plus 2P plus 5R. Okay, so you can use the distributive property only on the terms that are on the inside. So you can say negative 4 times what? 4 is negative 16. You're also going to say negative 4 times a positive 2P is negative 8p or minus 8p. Then you say negative 4 times 5r is minus 20r. And then plus the 16. Okay? Now you'll notice that the numbers, the real numbers, you can deal with. What is a negative 16 and a positive 16? 0. So what's going to be your answer?
Negative 8p minus 20r.
Minus 20r. All right, it's negative 8p minus 20r. Now, you're going to learn this in the next section, but what I've done here was called combined like terms. You don't have to know that phrase right now, but basically I use what's called combined like terms. And we haven't talked about what like terms are, but for right now, just know that negative 16 and 16 you can combine. You get 0. All right, let's look at this example. Looks like this. So negative 1 times 3x minus 2y, and then plus 6. Use distributive property. What's negative 1 times 3x? Negative 3x. What's negative 1 times a negative 2y? Positive 2y. And what's a negative 1 times a positive 6? Minus 6. You can't do anything else. No like terms.
Professor, if you wouldn't mind me asking, why did we change the symbol from subtraction into addition?
Where's the subtraction to addition? Oh, you mean here? Because that negative times a negative is a positive? That was from last semester. Okay, remember that? We talked before we started, I said you have to remember 2 things. A negative times a positive is a what? And also said a negative times a negative is a positive. Right. So now the signed numbers are things that you can easily forget. So it's understandable that some of you may not remember these signed numbers. But if you're one of these students that are not remembering certain things, go back to the book, to that section that deals with signed numbers, and just review it.
There's also some really good review videos
Yes.
on my math labs.
Yeah. All right. Now, the reason I put this example, so notice that this example, what number am I distributing?
-1.
-1. Okay, now this is going to be number 52. 52 looks like this. I'm just going to write out what it looks like first. That's a Q minus 2 plus 6R. Inside the parentheses is Q minus 2 plus 6R. Okay, now, you see that number 52, there's a negative out in front? It's understood, if you think about it, it's understood to be a -1. That's understood to be a -1. So I'm going to write this as -1 times Q minus 2 plus 6R. So if you need to rewrite it, rewrite as -1. And so now that looks like the previous example. Say it again? Yeah. All right, and so what will be the answer? Because a negative times a negative is a positive, and then what? Minus 6R, because a negative times a positive is a negative. Okay? So just remember about the negatives out front. You're going to see it again in a little while, where you're going to have 2 parentheses with the negative between them, with the subtraction between them. All right? Number 56, you have this. You have -1/5 times 10a minus 25b. All right. Now, some of you have a little bit of trouble with fractions. Don't let that throw you off. You have to deal with fractions.
What's that? -2 what?
-1/5 times 10a minus 25b. 25b. All right. So what I would do first, if you have to, go off to the side, since I'm dealing with a fraction, I would just say -1/5 times 10 for right now. Right, that for right now. And then you got to remember the stuff from last semester. First of all, remember that I can write 10 as 10 divided by 1. and then reduce first. It helps. You don't have to. You can multiply numerators first and then multiply the denominators, then reduce. But let's just reduce first. 5 into 5 is 1. 5 into 10 is 2. And now multiply. What's negative 1 times 2? Negative 2. What's 1 times 1? And what's negative 2 divided by 1? Negative 2. So what that means is this. So therefore, negative 1/5 times 10a is what? Negative 2a. That's what I just found. Okay? Now, for the next one, I would just remember, first of all, that a negative times a negative is a what? Positive. And for that one, I would just write it as 1/5 times 25, because I already took care of the signs. And you do the same thing as we just did. Rewrite 25 as 25 divided by 1. And then reduce, if you can. 5 into 5 is 1. 5 and 25 is 5. And when I multiply numerators and multiply the denominators, what does that equal? 5. Okay? So therefore, what I just found was that a negative 1/5 times a negative 25b is a positive 5b. All right. Okay? All right, so you got to remember some things from last semester, just like we did right here. All right, let's look at 58. 58. All right, 58 looks like this. All right, you have 10 times 4s. That's 4s. So 10 times 4s plus 6 minus 40. So 10 times 4s plus 6 minus 40. So you're going to say 10 times 4s, which is what? 40s, plus 10 times 6, which is 60. All right, and then minus 40, right? Okay, so the only thing you're multiplying 10 by, whatever inside the parentheses, that subtract 40 is not inside that parentheses. So you're going to say, and if you have to use those arrows, use those arrows. 10 times 4s is 40s, and then plus 10 times 6 is 60, and then minus 40. And now you know you can combine those real numbers. 60 minus 40 is 20, so it's the answer. Plus 20. Okay? 40s plus 20.
Now there, the only reason why the number is a positive 20 is because the 60, right?
A positive 60 and a negative 40 is kind of like if I had, since that's a plus right here, I can just say 60 minus 40 is 20. But you learned this last semester, just to remind you. So last semester, you had 60 minus 40. Obviously, you know that's 20, okay? But you also learned this. So let's say I had 30 minus, that's 30. 30 minus 50. So you learned last semester, and you have access to a calculator, but you learned last semester that you can always change subtraction to addition. Just like you can always change division to multiplication, you can change subtraction to addition. When you do that, though, you got to take the opposite of that number. So you learned that this is the same thing as saying 30 plus a what? Negative 50. And then you learned your rules. When I add two numbers whose signs are different, and they are, I subtract them. What's 50 minus 30? 20. And I keep the sign of the number that has a larger absolute value. So what's the sign of this number? Negative. So the answer is negative 20. So that's what you learned last semester in terms of those rules. I learned those rules, and those rules are in your book, in that chapter.
And it's the addition and subtraction of sign numbers that kill me.
I understand it. It's difficult to remember. And last semester you couldn't use a calculator with these. But in here you have access to a calculator. So if you can't remember your signed numbers, 30 minus 50 is, on your calculator, it's going to say negative 20. Just like on your calculator, if you had negative 30 minus 50, on your calculator, you better get negative 80. But last semester, using the rules, what you learned was this. I have subtraction. I'm going to change subtraction to what? Addition. But I got to use the phrase that says add the opposite. What's the opposite of a positive 50? Negative 50. Now I'm adding two numbers whose signs are the same. When they're the same, what do I do with those two numbers? I add them. 30 plus 50 is 80, and your phrase kept on. It said keep the sign. So it's negative 80. So those are things you learned last semester. But you have access to a calculator. Use it. Huh? I know, right?
I just wish it was easy like multiplication and division of sign numbers.
I know. Yeah, those are easy to deal with. All right, let's look at an example. Right, this example, you have negative 1/8 times 24 plus 16x. So negative 1/8 times 24 plus 16x. Now, some of you can do this in your head very easily. For instance, some of you can say right away, negative 1/8 times 24 is what? Negative 3. Okay? Others of you may have to do some work. You may have to actually write out 1/8 times 24. Now, I use 1/8, although it really is a negative 1/8 times 24, but you already know that a negative times a positive is a what? Negative. So if you have 1/8 times 24, you write 24 as 24 over 1, and then you reduce. 8 into 8 is 1, 8 into 24 is 3, and what's the answer? 3. So therefore, what's negative 1/8 times 24? Negative 3, though, right? Negative 3. And then again, some of you right away know that, first of all, negative times a positive is a what? Negative. So a lot of you know that a negative 1/8 times 16x is just what term? Negative 2x. For some of you, may have to write it like this. 1/8 times 16.
I'm that person.
16 over 1, right? You write 16 over 1, right? And then reduce if you need to. Now, you don't have to reduce. You could say 1 times 16 is what? 16. 8 times 1 is 8. But now reduce. What's 16 divided by 8? 2. So a negative times a positive is a what? Negative. So this 2, what we found now is that a negative 1/8 times a positive 16x is a negative 2x. So some work that you may have to do for some of you on the side. And you got to remember some things from last semester. So everything you've learned last semester, you're going to apply in here. And most of what you learn in here, you're going to apply next semester. Everything you learned in here, you're going to use in college algebra. So things progress. All right, now for 62, use your calculator, because that one deals with the decimal. Negative 16.6 times 2x plus 1 minus 0.1. So use your calculator in that one. So in your calculator, first of all, you know that a negative times a positive is a negative. And then on your calculator, just say what 0.6 times 2 is. What do y'all get? 0.6 times 2.
Negative 1.2.
All right, so negative 1.2. All right, was it? Trying to find my calculator, but I'm going to write this as negative 1.2x, so correct? And then what's and then for also a negative times a positive is a negative, so you can be subtracting. But what's 0.6 times 1? That one's easy. You need a calculator for that. 0.6. Is anything times 1 is itself. And then minus 0.1. Okay? All right, now, what are my real numbers? Negative 0.6. So you may say, well, that's subtraction. Yeah, but you got to remember subtraction is adding the what? Opposite. So even though you see subtraction, when you put this in your calculator, you're going to actually write it as a negative number. So negative 0.6, and then subtract what? 0.1. Or you can say plus, say what? So yeah, on your calculator, you would do something like this. You would say negative 0.6 minus 0.1, or you could say negative 0.6 plus a what? negative 0.1. Either one doesn't matter. You'll get the same answer. No. Use your calculator, please. Use your calculator. Negative point what? 7. So what's the answer? Minus 0.7. Okay? All right? Any questions on that part? So that's distributive property. Not that difficult. Not that difficult. All right, now let's go back and look at, this is on, now all this is on page, I'm going to go ahead and write it here. This is on page 599, or it starts on page 599. This is section 8.6, right? 8.6. All right. So let's look at number 4. Number 4. So the directions, you gotta look at the directions. So the directions in number 4 on page 599 says, all right, it says this. It says use, these are directions, use a commutative property. Use a commutative property to complete each statement. All right, so use a commutative property to complete each statement. And we talked about commutative properties. The commutative property for addition, a commutative property for multiplication. Remember, commutative property, the order does not matter. So number 4, they have this. They have something that looks like this, negative 2 times x. And they have that symbol for multiplication in there. And then they have equal blank. They have equal blank. So what do you think you'll put in the blank using the commutative property? X times a negative 2. All right, now I just want to say something. If you write it like this, that is fine as long as I can see that multiplication symbol. Because if I can't see it, then it no longer looks like multiplication. It looks like what?
Division.
No, subtraction. X minus 2. So a better way to write this would be since the 2 is negative, the better way to write this is like this: x times, and in parentheses put a negative 2. All right, so either one's fine as long as I can see that this really says x times a negative 2. Don't make it look like x subtract 2. Okay? So commutative property, in the blank, you just change the order. And that was commutative property of what operation? Multiplication. Number 8, suppose we had this. Still same directions. This time, let's suppose we had 19 plus 3y. What would you put in that blank? 3y what? Plus 19. So that's just where you change the order. Okay? All right, the next part. So this part was the commutative property. The next part is the associative property. All right, so let's look at this one. All right, so direction is going to say use an associative property. Okay, use an associative property to complete each statement. Use an associative property to complete each statement. So let's look at number. All right, number 10. Let's look at 10. Number 10 looks like this: 3 times x times y. It looks like that. So remember, the associative property, that's where you have the groups, right? And the order is the same, meaning 3 times x times y is the same as on the other side. But what do I group on the other side? 3 times x. Good. So you're going to say in parentheses 3 times x, and then times what? Y. Just like this. So remember, associative property, that's where you're grouping things. So in number 10, they group the last two You're going to say, well, that's the same as grouping what? The first two. Let's look at 16. 16. You have 6 plus R plus S. So again, this is the associative property of what operation here, number 16? Addition. So you still have three things. You're associated with two other friends, so you and two other friends. Here I'm grouping the last two. I could have grouped what? First two. So how would you write that though? The order stays the same. 6RS has been the same order now. 6 plus R and then what? Plus S. Okay. All right, any questions at this point? Say it again? No, it's an S. Now what I've missed, and that's R plus S. So 6 plus R plus S. Okay? All right, now, let's see. Okay. Let me see what I can do.